Okay, gang, we're back. Let's see, this would be video number 4. Right, this is part 4. Now we're going to go in the opposite direction. So in the previous examples, I was giving you the angle and you would give me the sides of the triangle. But now I'm going to give you the sides of the triangle and you give me the angle. So now we're going to do this the opposite direction. So the first thing when you do this is you have to unrationalize the trig if it's rationalized. So this would be equivalent to 1 over radical 2. So the very first thing you want to do is unrationalize the trig. Right, the next thing you do is actually the least obvious. And this is where you're going to get confused if you don't listen very clearly to this, what I'm about to say now. You have to look at whether the trig is positive or negative. So like this is positive, which means that I know what 2 quadrants the cosine is positive. The cosine is positive in quadrant 1. And the cosine is positive in quadrant 4. That goes back to the all students take calculus. The cosine is positive in quadrant 1 and quadrant 4. The cosine behaves like the x. The sine behaves like the y. So x is always positive on the right, negative on the left. So just the plus or the minus actually tells me what quadrants. So that is like really critical. The positive or negative of the trig tells what 2 quadrants the triangles are in. Okay, I'm just making a big deal out of that because it is so not obvious. It is so not obvious that I want to make a huge deal out of that. So the plus or minus tells you what 2 quadrants you're in. All right, now the next step. What the trig is equal to is giving you 2 legs of your triangle. So if this is the cosine, which it is, that means that this side is the adjacent and this side is the hypotenuse, right? So now I've gotten 2 legs of the triangle. So my angle is right here on each of these, and this angle is theta prime because we're going backwards. So the adjacent is 1, the hypotenuse is radical 2. For both of these triangles, the adjacent is 1, the hypotenuse is radical 2. So you have to know from the 2 triangles and the unit circle what the third side is. So this has to be the 1, 1, radical 2 because that is the only triangle that has a radical 2 as a hypotenuse. The other triangle has a plane 2. So one of the triangles has a hypotenuse that's a radical 2. That's the 45, 45, 90. The other triangle has a plane 2 for the hypotenuse, which is the 30, 60, 90. All right, so because I know which triangle out of the 2 they're referencing now because of the radical 2 and the 1, I know that this guy is 45 degrees. Because I know the triangle, I therefore know the angle. I'm going now from the triangle to zooming in on the angle. And because I know the reference angle, I therefore can calculate the standard angle. So remember, in quadrant 1, theta and theta prime are equivalent. So that means my first standard angle, right, my first angle is 45 degrees. That's this one. Now, for the second one, I have to rotate. So I know what theta prime is, but I want to know what theta is. So for this one, I have to rotate all the way around to quadrant 4. I have to figure out what this one is in standard position. So how do you think you're going to figure that out? If you're 45 degrees short of making it to 360, then that must mean that the original angle is 45 less than 360 degrees, right? Which makes this an angle of 315 degrees. Did my brain just do that right? 15 degrees, yes. So that means that my two answers are 45 degrees and 315. Now you can give these answers also in radians. So it would be pi over 4, and then if you did this guy in radians, it would be theta equals to 2 pi minus pi over 4. Let's see, if that's 8, then that's 7 pi over 4. You'd have to get like the LCD, right? You have to put that over 1 and get the LCD. You might find it easiest when you first learn these to stay in degrees, but try to also figure out what they are in radians. So again, just as a reminder, we are now going to figure out, we're going backwards, right? We're going in reverse to what I just did before. In the previous lecture, I would give you the angle, you'd give me the sides of the triangle, and now I'm giving you the sides of the triangle. You're going back and figuring out the angle in standard position. The reference angle is just the stuff in the middle. You have to go all the way to the standard position angle. Because if you tell me my answer is pi over 4 and pi over 4, I'll be like, wait, that's the same thing and they're both in quadrant 1. So what are you telling me, right? You actually have to give me an angle that would fall into quadrant 1 and an angle that would fall into quadrant 4. An angle that falls into quadrant 1 and an angle that falls into quadrant 4. So again, you start by figuring out what two quadrants you're in. When you figure out what two quadrants you're in, you draw the triangle. You then figure out what two sides of your triangle are. Once you know what two sides are, you find the third side. Once you know what the full triangle is, you then know what the angles are. Once you know what the reference angle is, you then go back and calculate in reverse what would have been the original angle given theta prime. Okay, gang, I'll try another one of these with you now. So here we go. Let's try it again. Let me see if I can get my camera to focus. 1 second there. Hello, camera. Let me just fiddle with it a second. Oh, man. Okay. My movie career. Okay, well, let's do this again. So I want you to just think for a moment what two quadrants you're in. And again, that's based off this sign here. By the way, this is going to be one of your homework problems, so I'm helping you with one of your homework problems. Also, I might as well just say this here. Your homework is now going to be 15% of your grade because I want to help you stay on track. If I make it part of your grade, you're going to be motivated to do it and therefore motivated to still figure out the rest of the material before we're finished in May. All right, if the sign is negative, the sign is like the y. If the sign is negative, the y is always negative below the x-axis. So that means that your two triangles are in quadrant 3 and quadrant 4 because that is where the sign is negative. If you do the all students take calculus, the sign is negative in these two quadrants. So all I'm getting that from is the negative. Now I'm going to fill in the two sides of the triangle. So the sign is the opposite over the hypotenuse. So this is theta prime. This is never the original. It's always theta prime when we go backwards. Okay, so the opposite is 1, the hypotenuse is 2 on both these triangles. So what does the adjacent have to be? Good. It has to be radical 3. Now this is a standard triangle, right? You have to memorize the two triangles in the unit circle. There's just two triangles you have to memorize. You got a 50% shot here getting this right just by guessing. Now hopefully you notice that one of the triangles have a plane 2 as the hypotenuse and the other triangle is a radical 2. If you don't know what two triangles I mean, there's only two of them. I'll write them here. It's a 1, 1, radical 2. That's 45, 45, 90. There's the first one. 1, 1, radical 2. That's a 45, 45, 90. The second one is the 30, 60, 90. 60 is always across from radical 3. 30 is always across from 1. Hypotenuse is always a plane 2. Those are the two triangles. If I haven't been super clear, that's it. You've got to figure out which one of the two triangles this one is, right? So if you're across from the 1, you're going to be this guy, because I have a 2 as the hypotenuse, right? I have a 2 as the hypotenuse, so it's this triangle. Not this one. This one has a radical 2 as the hypotenuse. All right, so if you're across from the 1, you're 30 degrees. So these are both 30 degrees. All right, now we're almost done, because if you tell me the answer on test 3 is 30 degrees and 30 degrees, I'm going to go like, oh, you're in quadrant 1? And you're going to go, no, I'm not in quadrant 1. I'm like, but 30 degrees, that's quadrant 1. And you're going to go, oh, I've got to be in standard position. Standard position means you have to rotate from the positive x-axis to the terminal side, like this. So you have to get me to here, to this terminal side. You have to calculate that. So you have to figure out, well, okay, if from here to here is 180 degrees, if from here to here is 180 degrees, I've gone 30 degrees past that. I've gone 30 degrees farther than 180. So I've gone 210 degrees. Again, if you're in radians, try to do both. That would be pi. 30 degrees as a radian is pi over 6. So therefore you've gone 7 pi over 6. Get used to doing them in radians, because when we get to chapter 5, we're going to be in radians almost predominantly. So don't shy away from radians, even though they look weird. But go ahead and use degrees if that helps you understand it. We tend to understand degrees the easiest. That's why I'm starting you in degrees, but get to radians at some point. All right, let's do the other guy. So from standard position, which is here, we've got to wrap all the way around to the terminal side of this one. All the way around to the terminal side of this one. So think about it. This guy is 30 degrees short of making it to 360. It's almost made it to 360, but it's 30 degrees short. So what does that mean this angle is in standard position? So your second answer, this is first answer. This I mean second answer. My second answer, I'm 30 degrees short of 360. So that must mean I'm at 330. Let's do that in radians. So that would be 2 pi minus pi over 6. You're going to have to get an LCD. When you do this, becomes 12 pi over 6. Minus 1 pi is 11 pi over 6. All right, so the two answers for theta here are going to be 210 and 330. Again, I'll teach it to you first in degrees, because your brain will register that right away. But then move it to radians, which is going to be 7 pi over 6 and 11 pi over 6. It's the same answer, I'm just writing it in different units. Okay, gang, that's it for this video. I actually have one more after this, and then that's it. Okay, catch you soon. Bye-bye.